Good afternoon, everyone. Thank you so much, Professor Skipniewski, for the introduction. And I would like to say also thank you for the organizer, Professor Raphael, sitting here, especially if you attended the opening speech by the host, the chair of this conference. You should learn many things. One of the aspects I learned from that is that construction, although it has productivity, however, it is the sector that is affected the most, especially for the health aspect, where construction workers are on the site and facing with emissions, especially for dust. And if you look further into the impact of particulate matters on human health, then you will see that even very low concentration of dust or particulate matters, then it also have a long-term impact on health. And especially now, while human workers are working directly in that zone. So my topic is today, I like to share is for deep learning for construction emissions monitoring with low-cost sensor network. And I need to acknowledge my PhD student, Huỳnh Nguyen, Trung Lý, my name, and Moshed Azi. Dr. Azi is the leader in the Department of Planning and Environment, who has funding for our project here. Quickly, agenda, rationale, introduction, framework, and probably I will tell on more on that. Okay, so rationale is that in Sydney, which is the heart of the southern hemisphere, there is a need nowadays with the population increasing, a development plan in order to build, and the government aim at the model for smart city. And in North Parramatta, the government approved a 160 million to convert into a hub that is sustainable. And one of the project that we have is here. Not only workers have to submit, subdue under the impact of dust emissions, but also the resident, because it is redeveloped in the heart of a suburb. And then the residents also complain about emissions. So the local government want to monitor that process. And probably I can run some quick video if it works here. Probably no noise, haven't sound incorporated in that, but I just explain that saying, okay, incorporate with the construction process ongoing, a lot of sensor is there, and one of the sensor to collect the data is emissions data, and we use a sensor network. It is a low cost, so that you can see that around that we put, and there are a number of problems with that. One of the problem is, I think I should move on. One of the problems is the missing data. So incomplete data, because the sensor network, it has a problem with supply, it has a problem with communications, and we don't have a perfect set of data. And one of the measure we propose is to use deep learning in order to remedy for that situation. So you can see that the dot here are on the low-cost sensing network and of the whole New South Wales. And over there, I think, sorry. Over there is the construction site, where you have, we installed a number of low-cost sensing network. It has, I think, represented in here. And what we propose here is dependable monitoring, meaning we set up a number of redundant sensors in order to retrieve the information, and we use deep learning in order to have a set of perfect information data. And we also use monitoring station, where we have a state-run station to benchmark with the data and also to do the correlation. So I think quickly to go with that. Well, the system framework is from here you have a number of low-cost sensing network with purple air and also some sensors. And what we did is data processing and preparation using the LSTM, which is a kind of a recurrent neural network, long short-term memory, together with the Bayesian neural network in order to compensate for the uncertainties. And a lot of metrics to be used in order to validate and verify the correctness of the information. So we start with data collection, data processing, and data preparation, and then using the model training in order to predict the data. And here is the structure. Probably we skip with that, a little bit of math. But Bayesian inference is used in order to integrate and to analytical retrieve the intractable piece of data where large number of model parameters are involved. Practical data collected from the site, you can see on the dot here is the sensor that we installed. We divided into 16 in fact zone on that site, and collect the data. So a number of evaluation metric, as I said, is used in order to verify and validate the validity of the quality of the forecast information. And we also benchmark recognize the method in the area. So the results going through some comparison of the metrics using, and the particulate methods here are 2.5 and also PM10, particulate matter 10, so the diameter. Okay, so the imputation capacity, and also we saying with the use of deep learning neural network, we can improve the forecast over existing techniques used. So in conclusion, I would like to say that low-cost sensing networks are used to collect emission data, and long short-term memory Bayesian neural network provides uncertainty quantification of monitoring data, enhances forecast accuracy compared to other deep learning benchmark models, and also improves the capacity of information retrieving over large missing gaps. The future work basically will incorporate construction shadow to enrich temporal features and to improve the inference accuracy. I like to open brackets to say that we apply that in order to integrate what we call multi-scaled emissions forecast, or multi-scale, meaning it can integrate to the server of Department of Planning and Environment to monitor the whole lot state emissions, and also at a suburb. And also, if we can go further with the advantages of low-cost sensing network, we can do even a smaller. In our demonstration, we have, for example, in this room, to pop up the information of that. And thank you very much. I think I don't exceed the